Today we're going to be working on confidence interval for population proportions. So there are ways or methods that we're going to be working on in completing our construction of the confidence interval for population proportion. We need to, one, establish the population of interest or the parameter of interest. We need to verify the three conditions, the computation, and to write and interpret the conclusion. So let's start with interpreting or finding the parameter of interest. So in this particular confidence interval problem, we are supposed to use 433 of the 1,548 randomly selected U.S. adults who were questioned who felt that unemployment compensation should be extended an additional 6 months while the country is in its economic downturn. So we want to use the information to construct a 95% confidence interval given the sample that we have. So our population of interest will be we want to estimate the true proportion of the condition stated above. So we have So this is to set the stage on our confidence interval computation. Now we are going to be working on the conditions. So there are three conditions: randomness of the sample, independence of the sample, and normality of the sample. So for our conditions, we know that the sample was selected or picked from randomly selected adults. And for independence, we're going to be using the big N greater than or equal to 10 times the sample size, or the 10% rule. And we know that this rule is satisfied based on the population of interest. And for normality, we're going to be using the law of large counts, or NP greater than or equal to 10, or NQ greater than or equal to 10. So let's establish what P hat is, because we're going to be using our P hat in this condition. P hat is going to be 433 divided by 1,548, which is approximately equal to 433 0.2797. So let's put 0.28 with a Q, which is equal to 1 minus P hat. So it's equal to 1 minus 0.28 is 0.72. So now that we have P and Q, we know that NP got some time. So all three conditions are now satisfied. Now let's write out the test that we're going to be using, and we're going to be using the one proportion or one sample proportion Z interval. So let's write it down. So we'll be using P hat, which is 0.28, and our Z star, which is 1 minus CL. One minus 0.95 divided by 2 is 0.025. And to find our critical value at 0.025, we're going to use inverse normal, second function, vars, go to inverse normal, which is number 3 under distribution, 0.025, which is equal to 1.96. So now that we have all the values that we need, we're now ready to compute for our confidence interval. So the formula is p hat plus or minus the critical value multiplied by the standard error, which is square root of pq all over n, where q is the implement of p. So p hat is 0.28 plus or minus 1.96 multiplied by the square root of 0.28 times 0.72 divided by 1,548. And using our calculator, we'll be able to generate the confidence interval. And I'm not going to show it anymore, but it's going to be 0.28. This, if we use the calculator, will be 0.0114. And when we multiply these two together, which is going to be our margin of error, is 0.0 or 0.022. So now that we have these values, just find the confidence interval, which is going to be at 0.258 and 0.302. So to finish our work, we're going to write the conclusion in the context of the problem. And notice that when we're writing out the conclusion, since we already established the parameter of interest, we don't need to rewrite all the terms in our conclusion, and we can just write out a general conclusion based on our result. So and this is now our confidence interval, or the interpretation of our confidence interval. And using the parameter of interest, we don't need to write out that we're referring for the US adults who feel that unemployment compensation should be expanded an additional 6 months, since we have established it already. And this is how we construct our complete computation or complete work for our confidence interval for population proportion.